Let us see this question. Question is a particle is propelled from the ground with the speed u at an angle theta with the horizontal radius of curvature is minimum at the. अच्छा ये they are asking actually what will be the radius of curvature at what point. See, it is projected like this at an angle theta. If we try to find out the radius of curvature here, here at this point mg is downwards. So actually the radius of curvature will be somewhere here. Perpendicular to velocity. This is again see this is 90 minus theta. So this will be theta. So the component of mg in this direction is mg cos theta. And to find out the radius of curvature, you can use the equation of circular motion. This will be mg at O, mg cos theta will be equal to mu square by r1. Is at initial point of projection. So r1 will be equal to u square by g cos theta. Okay. Now at any other point, if we move again like this, what happens is the horizontal velocity remains the same, which is u cos theta, but the vertical velocity keep on decreasing. Initially it was u sin theta, but now it keeps on decreasing, and at the highest point it becomes 0, but the horizontal velocity remains same. So what we know from this, that the resultant velocity, it's making an angle phi 1 here, suppose. So what will happen, v1 will be actually root over u cos theta whole square plus vy square, but vy is less than u sin theta, so obviously v1 will be less than u. Okay, resultant velocity will be less than u because vy is less than u sin theta. If it was greater than u sin theta, then v1 will be greater than u. So because v1 is less than u, at this point if we try to find out the radius of curvature, then again we'll do the same process, and here the radius of curvature mg cos phi 1 will be equal to mv1 square by r2, and here r1 r2 will be equal to v1 square by cos phi 1. Okay, but since this velocity is less, because v1 is less than u, so therefore angle increasing does not affect that much, so r2 will be less than r1. And similarly, if we go on to move at this particular point, the top point, at top the velocity will be again v2, which is u cos theta only, and it is again very much less than u because there is no vertical component also. v2 is equal to u cos theta whole square plus 0 square it is. So again it is very much less than u. So that means the radius at this point r3, which will be equal to v2 square by g cos phi 2, and here in this case it is g with this only 90 degree, because mg is acting this way and the angle between them is 90. U square cos square theta by g is the radius at this point, which is again least less than r2, and it is less than r1. So from what we infer from this, the radius of curvature is maximum at the point of projection, it is minimum at the highest point, so that is this is correct, and it varies from u square cos square theta by g to u square by g cos theta. This is correct. This is wrong. B is minimum at the point of projection. No, it is maximum. So this is wrong. This is wrong. So A and D options are correct.